This video introduces the vision recognition strategy for the target objects with highly reflective material. It also demonstrates how to configure the relevant parameters using the 3D target object recognition tool. Here, we take the example of steel rods. In this scenario, the steel rods feature a highly reflective surface and are closely fitted together. Thus, the 3D point cloud strategy doesn't work well for recognizing the rods. To address this, we need to combine deep learning for assisted recognition, typically using an instance segmentation model. With this strategy, the process of parameter configuration using the tool includes the following steps: train the deep learning model, preprocess the object point cloud, generate the object model and the pick point, import the deep learning model package, configure the 3D recognition parameters and set the output ports. Now, let's begin the specific operation. First, train and prepare the deep learning model package in advance. For details on model training, refer to the previous video training and application of instance segmentation model. Next, open Mech-Vision to enter hands-on examples. Click 3D locating. Select the corresponding project to create. Then, enter the project interface. Navigate to the step of 3D target object recognition. Click Config Wizard to enter the tool interface. Then, preprocess the object point cloud to filter the interferences and noises, so as to improve the recognition speed and stability. Click Set to enter the 3D region of interest setting interface. On the left visualization area, select the ROI. Adjust the frame to avoid interferences from the background, but leave some margins. Ensure that the ROI can cover the target object in the image. Upon adjustment, click Save and Apply. Click Next. Then, generate the object model and the pick point. Click Open Target Object Editor, and enter the target object library. Select the method to generate the object model. Since the steel rod is a cylinder with a regular shape, the object model can be directly generated. Then, the object can be created. Thus, select Basic Geometry here. Enter the object name. Select the geometry type as horizontal cylinder, and set the object dimensions. Click OK. At this point, the object center will be automatically generated. Click Next. Set the pick point. Adjust the pick point pose. In this scenario, to allow the picking of steel rods with different dimensions, the pick point is set on the surface of the rod. At this point, the object model and the pick point have been generated. Click Finish. Return to the tool interface. Click Update Target Object. The object model with its pick point appears in the visualizing space. Next, configure the deep learning model package. Open Assist Recognition with Deep Learning. Click Model Package Management tool. Import the previously trained package. Here, select the imported package. Switch the visualization view to Deep Learning Result. Set the 2D ROI. Select the region to cover the target objects and avoid interference, thus improving the recognition accuracy. Enter the file name to save ROI in ROI name. When finished, click OK. Based on the confidence values, set the confidence threshold for instance segmentation. Click Configure Inference. The threshold should be set to ensure as much target object recognition as possible while avoiding false matches. Therefore, just keep it as default here. Switch the visualization view to Recognition Result. Then, configure the 3D recognition parameters. To obtain more point cloud matching features, we select Surface Matching as the model matching method. Click Matching Mode and turn off Autoset Matching Mode. For both the coarse matching mode and the fine matching mode, select Surface Matching. Click Run Step to view the surface matching result. The selection of matching mode needs to be determined based on the specific features of the target objects. The documentation provides more details for this. Open the advanced mode. To improve the recognition accuracy, configure the fine matching settings. Select the performance mode as high accuracy, and the deviation correction capacity as medium. Click Run Step to view the result. Adjust the object confidence threshold to ensure recognition of all properly arranged top-layer objects. When setting the confidence threshold, please refer to the recognition result and the recognition report in the visualizing space. Ensure maximum target object recognition while avoiding false matches. In this case, all target objects have been successfully recognized. Therefore, simply set the confidence threshold as default. For the object count output, ensure the maximum output is set to match the number of objects in a full layer. For this scenario, it's set to 14. Click Run Step to view the output result. Then, click Next. Configure the output ports. In this scenario, the pick point differs from the object center point. Also, after recognition, particular pose adjustments are required, such as the orientation adjustment and pose sorting. These adjustments will be more accurate based on the object center point pose. Thus, select ports related to object center point to output the center point pose. Then, select original point cloud acquired by camera to output the point cloud information for subsequent collision detection. Additionally, as the orientation of incoming material varies, the bin position also changes. Therefore, select preprocessed point cloud for subsequent bin recognition. Other ports can be configured based on site needs. That's all for the configuration of recognizing the neatly arranged steel rods. The object poses recognized by the 3D Target Object Recognition tool can be used for further adjustments, including coordinate system transformation, pose orientation adjustment, pose sorting, and pick point transformation. This facilitates the robot to accurately pick and place objects. Further details about pose adjustments are provided in our videos, Pose Adjustment Tool Overview and Application. Each hands-on example in Mech-Vision has detailed documentation instructions. You can refer to the documentation for more operations.